Hi, everyone, and thanks for joining us. I'm Nancy Levesque, Communications Director for the Future of Privacy Forum, and welcome to this week's Privacy Chat. Today, we're talking with Cynthia Dwork, who is the Gordon McKay Professor of Computer Science at the Harvard Paulson School of Engineering and one of the inventors of differential privacy, about the basics of the differential privacy and how the field is progressing. We'll also discuss how the US Census is using differential privacy to prevent the risk of de-identification attacks on US Census data. With that, I'll hand it over to FPF CEO Jules Polonetsky.
Thanks, Nancy, and thank you for joining me on quick notice, Cynthia, and a huge honor. You've been one of my personal heroes for a long time because for a lot of our audience, who are people who work in privacy and data protection, we do it in a very legal and policy way. And what Cynthia has really brought to our entire field is a real scientific approach, a mathematical approach, a way to quantify this value that we're talking about and measure it and actually guarantee even with scientific proofs. We'll post some links because I've been amazed at the number of fields that are relevant to a lot of us who work in this area that Cynthia has done some landmark work on, and I encourage you to look at some of her work around fairness and others. So we'll post that. But today, we wanted to talk about differential privacy for two reasons. One, there's so much going on in the field as this has advanced from, a paper that she and Kobe Nissim and others wrote a number of years ago and laid out a theory to where it started to be increasingly used, but increasingly perhaps just by, companies with lots of resources and great expertise, the Microsofts and the Googles and the Apples. And as we've seen over the last couple of years, I'd say a democratization of the use of techniques that are measurable in this manner for a range of services. So I'm going to ask Cynthia to give us a little bit about that. But then, as Nancy mentioned, there's a hugely important issue. We are all aware of the efforts around the accuracy and the confidentiality of the census. And there's been this incredibly important intersection and our hope is that we can lay a little bit of the groundwork for those who are interested in those challenges. So anyway, Cynthia, welcome. Can you give some in the audience who maybe only generally know that there's this technique and it solves privacy problems, but it's very complicated. And what's the right way for a non-mathematician, non-statistician to think about differential privacy?
Sure. Thank you, Jules and Nancy, for inviting me to the show. So differential privacy really is a definition of privacy, and it's tailored to the statistical analysis of large data sets. So at its heart, differential privacy is just a mathematical promise. It says that anything that can be learned about you from the statistical analysis of a data set could be learned about you even if you were not a member of the database. So, for example, we might study a database and as a result learn that smoking causes cancer. And so if you are a smoker, we've now learned something about you. You are at increased risk of cancer. But you didn't have to be a member of the data set in order for that learning about you to happen. So we learn about the population as a whole, but not about the individuals. The term differential privacy now also refers to a large body of algorithms and lower bounds and impossibility results and possibility results and so on for data analysis that keeps this mathematical promise.
So we often hear about people almost describing differential privacy as a sort of technique that you use, you apply this, and then suddenly you've got the identified data. The way I've tried to simplify it, and I think this is the way you framed it, so tell me if I'm wrong, is there are a lot of different ways that I can add noise, use an algorithm to change, to mask, to do something to data so as to de-identify it. What differential privacy brought to us is a way to scientifically measure what you've achieved. And by mathematically having, a score that says, look, the risk here is very, very low, but also to sort of level set against reality, right? Because sometimes when we talk about the identification, we demand this sort of perfection. I could guess your birthday just because it's probably one of 365 days. And so you have a risk of somehow me learning something about you just by guessing. And what differential privacy in many ways does is there something that I've done here that because I know you're in this data set, I can say I'm now more certain that some information applies to you. Is that a fair way to think about it for us non-quantified selves?
So you're right that what differential privacy is doing is it's controlling the relative risk of something being learned about you in two different worlds. One world is the data set contains your data, and the other world is the data set is exactly the same, except just your data have been removed. And it's saying that kind of the ratio of any conclusion you might draw, or the ratio of the probability of reaching any particular conclusion you might draw, is essentially the same in these two worlds.
And so I think people probably have read about how some of the browsers have used this in certain areas. You've obviously been involved and observed the way a wider range of uses. So before we turn to the census, can you share from where you sit some of the interesting areas where researchers or businesses are using differential privacy, therefore allowing the kinds of uses of data we want for better decisions and so forth, without and guaranteeing minimization of any privacy risk?
Sure. So differential privacy, as you mentioned earlier, is being used very widely in industry. It's being used by Google and Facebook for example, reporting to the public COVID-19 mobility data. It's been used in the browser, as you suggested, to say, find websites that are sources of malware. It's used heavily in Microsoft Windows for reporting and machine learning, for predictive text language models, for creating Office workspace analytics. LinkedIn uses it for publisher tools. Facebook has used it to release a set of URLs that were relevant to political debate. Uber uses it for determining average trip distances. And more in the research area, it's been used in the Opportunity Atlas of Raj Chetty and John Friedman. It's used for all kinds of telemetry, and it's used in iPhones, and in fact, every single device that Apple creates. They use it for things like determining which emojis are becoming more popular, for finding deep links, look up hints inside of notes, and so on.
And one thing I think it's useful to make clear, the end product is typically a aggregate type data set, a statistical data set. This isn't a backdoor to letting somebody target you with ads or, work around, definitions of how to identify an individual in a way that can track you or the like. What one learns here is a research level set of information about a large grouping. And so in many ways where we want to understand, what's the effect of companies on society? Is misinformation spreading? Is hate speech spreading? What's the effect of Uber on traffic, right? There are areas where we want government, where we want researchers not having access to individual data that can be used in a harmful way to track you or arrest you or market to you, but where we want independent eyes looking at some of this critical data, and government data sets as well, where we want to understand, how is homelessness being combated? How are diseases spreading, as you exampled? So although we talk about maybe some of the uses that you see at browsers, or even some of the uses today that are being proposed for, reorienting, the system, the debates there typically are, well, then what are you doing with that data set at the end? And are you tying it back to people? But the core, activity is a way to do large scale research, shall we say. So we learn things about audiences at a large level, which is what, frankly, research is. Okay, so
let me just say, you're absolutely right, Jules. And a way to remember this is, could anything be tied back to me if I were not in the data set? If I weren't in the data set in the first place, there's nothing to pull on to tie back. And differential privacy says, therefore, there won't be anything to pull on to tie back, even if you are in the data set.
Exactly. We often see differential privacy used in a way that is linked to federated learning or multi-party computing. Can you give just a quick snapshot of why are these words linked together occasionally? What's the relationship between these different techniques?
So suppose you have a bunch of hospitals, say 5 hospitals, and they want to collaboratively be able to get the power of the data from all 5, but there are privacy protection rules that prevent them from actually sharing their data with each other. So what differential privacy in federated learning will let you do is it will will actually permit exactly what we want. It will permit the learning from the power of all of these while maintaining sort of privacy versus hospital versus hospital privacy boundaries.
There have been a couple of guides, or even almost like comic books, or sort of, differential privacy 101s that folks have done. We'll post some links to that for those of you who are newer to this and who want to, spend a little bit of time just getting the concept a bit further. But what I'm going to do now is turn with Cynthia perhaps to the interesting reason why, in addition to getting this snapshot, we wanted to talk about this issue now. I read, I guess, a New York Times article, maybe it's 2 years ago, a year ago, that was shocking, but evidently this was something that the research and the census community, was already aware of. And this was a report of an attack of research that was done. And the accusation was that by using data that the census releases, this expert could identify certain individuals. And this was shocking because the census typically has been the first class, frankly, organization in government or anywhere in maintaining confidentiality of data. We all know that if you're nervous about that data being available to anybody, other agencies, the public, people won't fill it out. Vulnerable communities, immigrant communities, all of us who maybe don't want some of the detailed information about demographics and income and size of households and so forth available, trust that there are legal commitments, there are criminal penalties. The census has been a real first-class entity because that is what their core mission is. They know there is no census without a strong degree of confidentiality. But they do release a lot of data because there are a wide range of researchers. We allocate congressional seats based on census data. We spend a huge amount of the government funding. A lot of times it's per population. So we need to know what's the population in each state, redistricting. There are huge communities out there, and we usually don't pay attention until it comes to congressional times, counting votes, or if you're working in an area where this is interesting to you. You probably consume census data when you read reports, and we say, well, how many people have left California to another state? The census at the end of the day gives us the real, information that researchers end up relying on. So was this attack as serious as it seemed? And what did you think? Were you aware of some of those concerns already?
So yes, the attack is as serious as it seemed. And in fact, there's another attack that was launched by the Bureau itself, which I'll get to in a minute. But you asked whether we were aware of this. Sure, we were aware of this. We were aware of this in the following sense. There's something that we know of as the fundamental law of data reconstruction, or the database reconstruction theorem. And it says that sort of overly accurate estimates of too many statistics from a given data set completely destroys privacy and allows the data set to be actually reconstructed, rebuilt. So this theorem, which is due to Dinur and Nissim, was published in 2003, and there have been many variants and strengthenings of the basic result. So this is the database reconstruction theorem. It is a fundamental mathematical law, 2003. So of course we knew, and in fact, it was precisely this that ultimately led to the invention of differential privacy, because I said too many, overly accurate. So the definition of what is too many depends on how accurate you mean. And we started saying, well, what if we just had reasonably accurate statistics, say with errors less than the sampling error, but we cut off the sort of attack before we reached the too many for that degree of accuracy. And we realized we could do a lot. So that was kind of the beginning of differential privacy. So what happened? What was the bigger attack? The bigger attack was launched by the Census Bureau themselves. So the Bureau releases two kinds of information. It releases statistics or tabulations and summaries, and it also releases kind of individual microdata records, about 1% of the population. The attack did not use those individual microdata records. It only used the big statistics. So the Bureau released, I've heard many numbers, 11 billion, 7.7 billion linearly independent, but huge numbers of statistics on the population of, which was about 308 million people in the 2010 census. So normal, ordinary Census Bureau release of these statistics. They then applied the database reconstruction theorem, the basic reconstruction attack. They didn't use any confidential data to do this reconstruction. Anybody with a computer and access to the statistics that the Bureau had published can carry out the same attack. So they do this reconstruction. This gives a bunch of different fields that, values that people have filled in. No names, no addresses, but values. Race and ethnicity and other sorts of things, age, so on. They then used commercially available data sets that were available in 2010. So now commercially available data sets are even more rich and detailed. But they used the 2010 data sets, and they carried out what's called a linkage attack, where they linked reconstructed records to records in these commercial databases, acquiring personally identifiable information through that linkage. So let's say that they did successful linkage to this commercial data. We call this a putative re-identification. Then finally, to see how well they did, they compared the putative re-identification to the confidential data. And they found that they had carried out a successful reconstruction and re-identification attack on the data of 52 million people, confirmed re-identification. So this was real. It was not just a pencil and paper exercise anymore. This was real, and it was large scale. And this is just one attack using 2010 data. With 2020 commercial data, you can do better. And other attacks might, in fact, also reconstruct even more.
So here we are at this really incredible crossroads. The census is, I'll say complete, but we've done the counting. We're now doing the math, and we need to release information because it's 10 years.
Yes.
The world has changed. Congressional seats, population, resources the Biden administration is going to spend if the bills pass a huge amount of funding on infrastructure. A lot of that may be targeted again towards things like population or regions and all that. So the sense and constitutionally, I think we must have a census and we must release the count. It's part of the core data that the country uses for a range of purposes. And we now know that if we simply release the data the way we've always done it, it is going to be feasible for anybody with the right sort of skills to identify potentially a huge swath of the country and learn really specific information that we have guaranteed would be confidential. So yes, we need consumer privacy legislation that deals with, should all this data be out there commercially and floating around? That'll help, but that's not going to solve the problem, because I think what has been identified is that when you release multiple data sets, some I think sometimes maybe call this the mosaic effect. I don't know if that's truly the same thing, but the point being, lots of data sets that are all themselves aggregated can be overlaid in a way that leaves us with just one or two or some very small number of people in a category. And then that makes it pretty trivial to go ahead and find out who those people are. So the census, being aware of this, took on the challenge of using techniques that would add some noise to this data, working to put algorithms in that would change the data in some manner, and allow them to publish the key data sets, but this time be sure that in no place were they leaving those ones and twos and threes. And this seems to have created a bit of a stir, because there are people, as we discussed, who rely on the census data and have been working with it in the same format and are worried now that the information is going to be different, is going to be wrong, key information is going to be blurred out. Clearly we need to be sympathetic to some of those concerns. What's been your reaction to those who say, I've done 20 years of research using the data looking like X, it's now going to be Y, that's wrong, that's different?
Great. So before I answer your question, I just want to comment that in some sense, as bad as the ones and twos and threes issue is, that's not talking about the large scale weaponization that I'm describing that you can carry out with a reconstruction attack, where you can create a list of essentially all of the, name your favorite vulnerable population, families of this type in the country. And anybody could create such a list. And so just want to be clear what it is that we're worrying about.
That is actually, I don't know that I fully appreciated that. I guess the early attacks seem to be narrow, but the census actually proved in their work that it's actually wide swaths of America that would be exposed.
That's right.
Wow.
So since you can reconstruct, you can now make a list, all of the gay households in the country, all of the Hispanic households in the country, all the mixed race households in the country, because that information is on the form.
If we went ahead and released the data.
If we don't have adequate privacy protection, that is the risk, the weaponization of census statistics, even without the IPOM's microdata. Okay, so that's very important. It's very important as a starting point for why the Bureau decided that a stronger and more formal and rigorous method, rather than the ad hoc techniques that were used in the past, would have to be implemented.
Oh, so you mentioned ad hoc. So there's always been work done, right? We've never been simply putting together giant summaries and publish them. There's always been a lot of data hygiene and work done to make this fit for use.
That's right, Jules. So there's always been a lot of work done for the purposes of protecting privacy. And we should also mention that there are other sources of inaccuracy. So vulnerable populations, I guess you said this earlier, are routinely undercounted. Children are routinely undercounted. Young children are routinely undercounted. Immigrants are routinely undercounted. there are many, many sources of inaccuracy. And so we also need to have this perspective of, okay, we are introducing more inaccuracy for the purposes of protecting privacy, but what is the scale of what's being introduced compared to the scales of the errors that are already there? So the key point that we must keep in mind is this reconstruction theorem tells us that any method that will defend against the enormity of the technical revolution of the reconstruction theorems must introduce inaccuracies. Overly accurate estimates of too many statistics is completely non-private, completely destroys privacy. The Bureau could decide to release fewer statistics, but if we're going to be releasing the kinds of things that we've been releasing in the past, then there must be inaccuracy in order to prevent this weaponization. As for the researchers who specifically have worked with IPUMs, it's hard. There's no denying that the ways that people had access in the past can lead to major problems now. And this sort of says that we need to train people in how to work with the privacy-infused statistics and to learn how to carry out research on these. It is possible. Gary King gives lots of examples, and we've also seen it in the Opportunity Atlas. But it's a sea change in the life of people who are used to having, so academic researchers who are used to having access to these kinds of information.
The critique sometimes has been, hey, look, when you publish some of these results, there are negative numbers. How can there be a negative number of people sort of in an area? This is all pretty crazy. And the reality is that does, sound a bit odd, but the reality is what is happening a bit is there's a little bit of, normalization happening so that some of the overlaps and the threats are masked. And, for those who work in statistics, it's perhaps not as jarring as to the general public. But what can you comment a bit more about, somebody raised to me at some point, says, well, there might be a very small Native American population here, and all of a sudden they're not there. That can't be. Whatever you did there just, erased that community. How should we be thinking about some of the rounding that is happening for privacy, but where we need some way to reflect that those people exist and that they need to be represented in the data in some way?
Right. Okay. So there are two things to keep in mind. First, differential privacy is sort of an equal opportunity privacy technology. It protects each individual to the same extent. Now, if you think about this in terms of adding a little bit of noise to cover the presence or absence of any single individual, that's the noise, the amount of randomness that you introduce. If you have a very large population and you add a little bit of noise, well, what you've added, your noise to signal ratio is tiny. It doesn't matter. Large population, a little bit of noise, it's the same thing. But if you have a very small population and you're still adding that same amount of little bit of noise, now your noise to population ratio is much worse. This is an unavoidable consequence of giving privacy to everybody equally. Okay. So that's the first thing. Second thing, you mentioned negative numbers. The Census Bureau's algorithm, which is called top-down, actually works in two phases. The first phase computes differentially private counts. And some of those counts, as you noted, might be negative. If we've added some negative noise to a small number, or even zero, because you have census blocks, many, in fact, I think 1.9 million census blocks in this country that have zero populations. When you add noise, about half of those are going to show up as negative. we know small negative numbers means that the original number was very small, but it is jarring if you are not, used to thinking in these terms. So, and the Bureau's algorithm has a second pass, which is called the post-processing pass. It has no implications on privacy and doesn't touch any of the original data, only looks at these collections of counts with some of their negative numbers and rearranges things in order to get rid of negative numbers. But they keep the total number of people the same, so they move people around in order to cope with these negative numbers. That has the effect of drawing population away from urban areas and scattering the population around uninhabited areas. The Bureau says that the sources of bias are only in the post-processing. They're not due to differential privacy, and that most of the error comes from the post-processing. I have heard that the Bureau will be releasing these noisy, sometimes negative counts as a research product. And I'm very excited about that. I think it's a wonderful step.
I hope we've provided a bit of a flavor of what you can see is a deeply challenging and incredibly important issue, really at a national level. We have a threat to the privacy of just about every person in the US because of the reality that we have a census, we've had a census, we need the census, and mathematical techniques on the outside have gotten good enough, and we've perhaps become sophisticated enough to understand the risk, and so we clearly need to apply anything we can, and differential privacy has given us an incredible tool that's been tested and studied and can be done in a fairly open and transparent way, especially if the census shows its work as it's been frankly doing extensively. It clearly is going to create some strain because some people who worked with data in one manner, are going to have a data set that has changed, and of course it's changed. It's been 10 years that the data has changed, and they may need to do work, and they may have some strain to sort of normalize and sort of understand their statistics. It's work that can be done, but I think we can appreciate that there are challenges that are going to be created, but we don't have a choice. We can't risk releasing the data in the way we've done in the past. And frankly, it is going to enter into this political debate, because if we're counting and we're saying, here's how many people are in this area, in that area, people who care about voting rights, people who care about congressional reapportionment, and who may worry that the end result changes something in a way that's not in their favor. And anybody who sees a change that is not in their favor wants reasons to argue that it's the math, that if they could only flip it back to the old way or a different way would be better for them. And I think, we need to hear that out, but at the end of the day, we need to understand that it simply isn't going to be acceptable to do this the way we've done it in the past. And there isn't anything better that has been tested and studied and analyzed and shown to be scientifically and mathematically strong the way differential privacy is. If there was another better technique, Cynthia would be proposing it, and other leading experts here would be saying, go in this direction. This is as best as we've got. And at the end of the day, we need to move forward. But we'll post some links, not only to some of the differential privacy explainers. Dana Boyd has been doing a good amount of writing about some of the policy issues and so forth. Our goal here, just to sort of set up a little bit for the broader audience, the kinds of issues and the importance. So, Cynthia, any key last thought you think we should put out that I didn't raise or that you didn't get to make?
I think we've done a great job. Thank you, Jules.
Thanks, everybody. Happy Passover for those celebrating. Good Friday to those celebrating. If I'm missing any other key holidays, it's a busy week, and I know how busy everyone is. So we appreciate you taking the time to speak with us and watch the video. Cynthia, thank you so much. Honor and a pleasure. Always learn when I speak, and look forward to continuing our conversations.
Thank you, Jules. The honor and pleasure are mine.
Bye, everybody. Happy Friday.